Welcome to the Cayman Islands. Out in these waters lie some of the most remarkable reefs and sea life in the world, and as a dive master I've had the pleasure of introducing thousands of divers to their beauty. One thing almost all divers have in common when they see what's below is their desire to capture that beauty on film so that they can share the excitement with friends back home. They realize that mere words, no matter how eloquent, can never explain what photography can show. Each year, Fisheye enables divers from around the world to learn the techniques of underwater photography and master the equipment needed to capture those breathtaking shots. We'd like to invite you to spend some time with us as we look at the Nikonos V, the compact, easy-to-use underwater camera by Nikon. It's the same camera that many of our divers prefer because they believe it's the best in the world. We'll show you how to assemble it, test it, and prepare it for your first trip.
Then, once you're familiar with your gear, we'll show the basics of underwater photography that we've learned through years of experience, diving and shooting throughout the world. We'll talk about exposure, focus, and shooting techniques such as a choice of subject matter and composition.
Even if you're an accomplished land photographer, you'll want to pay special attention as we explain the differences between land photography and underwater photography. By preparing adequately before your trip and following a few basic rules, you'll be able to capture those memorable images on your very first underwater photographic expedition.
Your Nikonos V system comes as three separate components: the camera, the lens, and the speed light. As you watch this program, or after, you may want to refer to the Nikonos V instruction manual provided in the camera box for more detailed instructions and technical specifications, such as which camera batteries are recommended. Start out with a clean workspace. A dining room table is usually a good place. I like to put a big towel down to protect the surface of the table and the camera components. After you open the camera box and remove the camera, begin to familiarize yourself with the camera and its controls. Like land cameras, the Nikonos V has standard features including an ASA speed dial, a film rewind crank, a shutter speed mode selector dial, a frame counter, a shutter release and a shutter release lock, a bayonet lens mount, a battery compartment, and a film advance lever. Let's start by opening the back of the camera. You will find a camera back release lock latch and an orange lock button on the left side of the camera. While pushing the orange button, twist the lock until the red lock mark aligns with the white index mark. As the rear compartment door swings open, you'll notice a slight pressure outwards caused by the black rubber O-ring. This O-ring provides a waterproof seal and is similar to several others you will see on the camera and strobe head. We will discuss the proper maintenance and lubrication of these O-rings in just a moment. Once you have familiarized yourself with the camera, your first job will be to insert the camera batteries. Using a nickel or a quarter in the slot, twist open the lid and remove the battery chamber clip. You'll notice a black rubber O-ring on the threaded holder. Using the batteries provided, or acceptable replacement batteries, such as one Duracell 3V lithium or two Duracell 1.5V silver oxide batteries, place them into the battery clip. A guide etched into the black plastic clip indicates the correct polarity placement of the batteries. Be sure to double check for correct battery orientation using these guidelines. To replace the battery clip, press down with the thumb to seat the cap evenly. Turn it 1/4 of a turn counterclockwise until you feel the threads snap into place. Turn the cap clockwise until it's flush with the surface of the camera body. If you feel even the slightest sign of resistance, back off the cap and begin again. We want to be sure we don't screw the cap in unevenly or cross-thread it. After you have installed the batteries and replaced the battery clip, you should next mount the lens. Remove the protective plastic cover from the front of the camera, then remove the 35mm lens from the lens box. Note the O-ring forming a waterproof seal where the lens mount meets the camera body. With the silver and black knobs in a vertical position, place the lens into the bayonet mount, pushing in lightly, and twist 1/4 of a turn or 90 degrees until the lens snaps into a horizontal position. Although the lens may be twisted on in either direction, you may wish to align these controls so the knob for the f-stop is on your left as you look through the lens. In this way, all markings on the lens will be in the proper upright orientation when you turn the camera back towards you. Now that the lens has been mounted, twist each of the two knobs to familiarize yourself with their function and how they affect the aperture or f-stop scale and distance scale. You should take special note that unlike many land cameras, f-stop and distance function are controlled by these black and silver knobs. Any attempt to turn the lens to set these f-stop or focus controls, like you may be used to on another camera, will result in the lens twisting off the camera. Turn the knob in your right hand to adjust the focus. You'll notice the red numbers indicate feet and the black numbers meters. The range of your focus control is from 2.75 feet to infinity. If you have twisted the lens on as recommended, your f-stop knob can be turned with your left hand, and you can see that as you turn it, your f-stop range is from f2.5 to f22. If you're not familiar with what an f-stop is, we'll cover that information in the second portion of this program. As you open and close your iris, that's the one in your left hand, you'll notice the two red pincer-type depth of field indicators on your footage window open and close to show the range which will be in focus for any given f-stop. This depth of field phenomenon is often confusing to new photographers. Depth of field is simply a zone of focus in front of and behind the subject you've focused on. It provides you with a margin of error in the event you've not focused accurately. If this sounds confusing, we can use a front element of your lens to help explain the depth of field. For example, let's say your focus is set to 4 feet. If we were shooting this at f2.5, your red pincers indicate you have virtually no depth of field. Watch what happens as you turn your iris to f22. The red pincers move to indicate that your depth of field is now from 2.5 feet to 10 feet, a zone of focus over 7 feet deep. There will always be more depth of field behind the subject than in front of it. About 1/3 of your depth of field will be in front of the subject, and about 2/3 of your depth of field will be behind the subject. So if you're unsure of the distance, overcompensate towards the greater distance choice when focusing. When you need to remove the lens, pull out gently and twist it 1/4 or 90 degrees into a vertical position. With your lens now in place, it's time to look through the viewfinder. When you look through the viewfinder, you should remember that your Nikonos V is not an SLR or single lens reflex camera. In other words, you're looking through the viewfinder, not the lens. The white etch marks serve as guidelines to what your lens will capture. The top frame line marks are for normal 35mm lens framing. The lower marks, about 10% down from the top, indicate framing for close subjects less than 4 feet away. We can also use the viewfinder to check the batteries. To check the batteries, turn the shutter speed dial, also known as the mode selector dial, to A, or aperture priority mode. Unlock the shutter release lock, advance your film frame counter to number 1. While aiming the Nikonos V towards a light source, depress the shutter release lightly. LED readouts in the viewfinder should become visible and change as the light source changes. LED readouts should also change when you adjust your f-stop control. You should see the shutter speed lights changing from say 30 to 60 to 125 for example. LED arrows on either side of the shutter speed scale indicate underexposure and overexposure. If the LED readouts don't appear, double check to make sure that the camera batteries are placed in the correct fashion. One habit you should stay in is to check the O-rings. O-rings can be found inside the back cover of the camera, on the camera battery clip, on the lens mount, and as we'll see in a moment, on the speedlight battery cover and the strobe sync cord. These watertight O-rings should be inspected regularly for cracks and cuts, and properly lubricated to prevent leakage. To remove the O-rings, pinch the rubber ring with your fingertips until a slight bulge occurs. Then gently twist it from its seating. Never use a sharp object or credit card to help pry up the rubber. With the O-ring removed, check for debris in the O-ring channel where the ring is ordinarily seated. When necessary, a cotton swab can be used to clean this channel. To lubricate, place a small amount of the provided O-ring grease on your fingertips and rub it onto the ring. As you do, feel for any cracks or irregularities. After lubricating, place the O-ring back onto its seating, stretching it slightly into place. Before closing the camera back, run your fingers along the seating surface to check for debris. Next, let's assemble the speedlight. The speedlight comes in 5 pieces: the strobe head, the camera tray, an arm, the joint, and the sync cord. Take a moment to familiarize yourself with the various components of the speedlight head. You'll find a battery compartment, a ready light, a switch with 4 settings plus an off position, and a sync cord socket. To start your speedlight assembly, place the batteries in the head. Hold the speedlight head facing up so the battery cover is on the bottom. Loading batteries in this head-up position is a good habit to get into, so in the future water will not get into the battery compartment should you need to change batteries after a dive. Remove the battery cover at the back of the speedlight head. You'll notice the O-ring. Slide out the black plastic battery holder. Insert 4 AA batteries into the battery holder, following the guide on the black plastic holder. Then slide the battery holder back into the battery compartment and twist on the battery cover finger tight. The holder was designed so it can only slide back in the correct way. Now you're ready to attach the speedlight cable. Your speedlight cable is designed so that you can only attach the cable ends correctly. Attach the larger of the 2 ends of the cable to the speedlight head socket. The smaller cable connector is inserted into the camera sync socket on the base of the camera. Align the red dot on the cable to the white dot on the camera. Insert the cable and twist the silver knurled knob. Next, you'll want to test the speedlight. To test if the TTL circuitry of the strobe is working correctly, turn the switch on the speedlight head to the TTL or through the lens position. You'll hear a whistle and the ready light should come on within a few seconds. Double check to make sure the camera mode is in the A position. Open the camera iris all the way by turning the f-stop knob to f2.5. Aim the speedlight head towards the camera a few inches away from the lens. Keeping an eye on the ready light, trigger the strobe by pushing the shutter on the camera. You'll see the speedlight flash. The ready light should come back on within 1 or 2 seconds if the TTL circuitry is working properly. If it's not, your ready light won't come back on for 7 or 8 seconds. Once you've completed the TTL circuitry test successfully, turn the strobe head indicator to the off position. Now you're ready to assemble the Nikonos V system. Start by mounting the camera on a flat black bracket using the tripod socket. Slide the silver metal plate of the strobe joint arm into the mounting head of the strobe unit. You'll notice this joint will enable you to adjust the tilt angle of the strobe head. Once you've inserted the metal plate properly, tighten the tilt knob. The flat lever at the rear of the mounting arm will also enable you to adjust the height and the angle of the speedlight head. Slide the strobe arm into the slotted camera bracket. 2 short pegs help to keep this mount in alignment as you tighten the lock knob. Pick up the system to get a feel for its balance and weight. Underwater, this system will feel almost weightless.
We strongly recommend that you do all of this preliminary work the night before the shoot, and don't try to work on your camera system near the water or salt spray. Now that we know about our Nikonos V camera system, we're going to spend the next few moments looking at what makes a good picture. Many of you may already understand the principles of photography from shooting on land, but we'd like to remind you that many of the principles of underwater photography are different. Let's begin with the basics. What makes a good picture? Well, if you've ever had to sit through a friend's boring slideshow, you'll probably agree that the ingredients for a good picture are proper exposure, sharp focus, and an interesting choice of subject matter.
In many respects, your Nikonos V is very similar to the first cameras ever used. It's basically a light tight box with a lens on the outside and film on the inside. The lens enables us to put light onto the film in proper amounts. We call this introduction of light onto the film exposure. Exposing the film with the proper amount of light is really the result of three interrelated activities: film speed, shutter speed, and f-stop or iris. The film speed is a way of describing how sensitive your film is to light. It's assigned ISO or ASA numbers, usually somewhere between ASA 16 and ASA 1000. The higher the number, the more sensitive the film is to light. The lower the number, the more light is needed to expose the film. For example, film with an ASA rating of 64 is considered slow and will need comparatively more light. It's usually used in bright sunlight. A fast film with an ASA rating of 1000 requires less light and is so sensitive it can be exposed under bright candlelight. Film speeds also determine the look of the finished product as well. Slow films, those with an ASA rating up to 100, will have richer color rendition and finer grain. Fast films, those with ASA ratings of above 200, will have less vivid colors and will not appear as sharp because they have more grain. You will also want to make a choice between print films and slide films. Print films provide you with negatives from which prints are made. These print films come in a variety of ASA ratings and each has the suffix color in the title, such as Kodacolor. Prints are fine for passing around to your friends to look at or for putting into a photo album, but we recommend you use reversal or slide film. The slower reversal films result in slides with vivid colors and fine grain and are the first choice of professionals and serious amateur photographers. Slide films can be identified by the suffix chrome in their names, such as Kodachrome or Ektachrome. When we dive, we use Kodak Ektachrome with an ASA rating of 100 for sharp, crisp slides with an excellent color rendition, the kind of slides you'd be proud to show your friends. Since you know which film you want to use, and your system is together, let's take a moment to practice loading the film into the camera. On your vacation, you should always load the film prior to getting onto the boat to avoid the light, heat, sand and salt water on the dock or boat. To load the film, open the camera back using the camera back release twist lock and orange safety lock button. Pull up the hinged pressure plate and lock it behind the film advance lever. Insert the roll of film into the film cartridge chamber and pull the film end across the gate as you would while loading your land camera. Insert the end of the film into the slot and engage it on the film take-up spool. Gently release the pressure plate and snap it into position. Cock the film advance lever, making sure the film is being taken up on the spool and that the film advance sprockets are aligned with film perforations. At this point, I always double check the ASA of the film and the number of exposures available on the roll and make a mental note of them. Close the camera back and lock the release. Lift the rewind crank and slowly rewind until you feel tension, indicating you've taken up the film slack. With the rewind crank still in the up position, advance the film until the frame counter indicates number 1. As you advance the film, notice if the rewind crank is rotating in the opposite direction of the arrow on the handle, that is, counterclockwise. Then push the rewind crank down. Referring to your recent mental note, immediately set your ASA ISO rating to the appropriate setting as indicated on the film canister. Lift the film speed dial and turn it to the index mark pointing to the proper ASA speed. By telling your camera the ASA speed, you've now fixed one of the variables controlling the amount of light which exposes your film. The next variable which controls the amount of light is your choice of aperture. Aperture is also referred to as iris or f-stop. If you look down into the lens and turn the f-stop control, you'll see the iris become larger or smaller, just as the iris in your own eyes. With a lot of light, your iris can adjust to become smaller. With less light, your iris can adjust to become larger, thus capturing more light. Your camera is the same as your eye, except each iris size or aperture setting has a number assigned to it, and this is where many people become confused. The confusion occurs because the smaller iris sizes have larger numbers like f22 and f16, yet the larger iris sizes seem to have smaller numbers like f2.5 and f4. If this is still too confusing, just remember, the larger the iris opening, the smaller the f-stop number appears. The smaller the iris opening, the bigger the f-stop number appears. If you have too little light and need more, open your iris to a size with a smaller number. Conversely, if you have too much light, then you have to close down your iris to a larger number. Let's talk about our third variable for proper exposure, shutter speed. The shutter speed determines the length of time, in fractions of a second, that light strikes your film. You can see on your mode selector dial a shutter speed indicator that gives you a choice of a 30th of a second, a 60th of a second, 1/125th of a second, all of the way up to 1/1000th of a second. Each time you change from one speed to the next fastest, you're doubling the speed that the shutter opens and closes. For example, 1/60th of a second is twice as fast as 1/30th of a second. 1/125th of a second is twice as fast as 1/60th of a second. While we're looking at the mode selector dial, you'll also see other indicators. A for aperture priority, M90, which stands for mechanical 90 and will set the shutter to a 90th of a second. It can be used to manually trip your shutter should your batteries wear out. When B, or bulb, is chosen, the shutter will stay open for as long as you depress the shutter release button. This setting enables you to take time exposure shots. This is a mode which we don't ordinarily use in underwater photography. R, or rewind, will disengage the film sprocket drive and enable you to rewind your film when finished. When we shoot with our underwater speedlight, we'll want to place the camera mode selector in the A position. A stands for aperture priority, and it tells your camera that you will be selecting your own aperture or f-stop. The camera's electronic metering system will then calculate the proper shutter speed for the ambient light conditions. Again, you select the aperture or f-stop. The camera calculates the proper shutter speed based on the light conditions. Before we begin our discussion of aperture priority, be sure you've advanced the film to frame number 1. Then, by aiming the camera at a light source and looking through the lens, and depressing the trigger lightly, you will see the LED readout. As you turn your f-stop dial, you'll notice the camera adjusting the shutter speeds according to the amount of light the light meter sees. Once the camera determines the amount of light available, a balancing act occurs. If you open the iris to allow in more light, the shutter speed increases or becomes faster. If you close down your iris, the shutter speed becomes slower. This balance between the iris and the shutter speed is called reciprocity, a big word that really means if one goes up a notch, the other goes down a notch to maintain correct exposure. Think of it as a seesaw. For example, if you've chosen an f-stop of f5.6, the camera may calculate that with your ASA 100 film, the shutter speed has to be 1/125th of a second. If you choose to close down your iris one notch to f8 under those same lighting conditions, your shutter speed will increase one notch to 1/60th of a second. Again, if you move one up, the other goes down and vice versa. The water of the Caribbean acts as a giant blue light filter. It takes away the warmer colors, and the deeper we dive, the more colors are filtered out. At about 30 feet, even the brightest of red, orange, or yellow wetsuits appear to lose their color. Many of the beautiful colorations of fish and coral are lost not only to the naked eye, but also on your film. The speedlight, just 3 feet from the subject, enables you to capture all of the brilliant colors of the reef, because the light from the strobe does not have to pass through 30 or 50 feet of blue water. For this reason, 95% of what we'll be shooting underwater will be shot with the speedlight. The electronic circuitry of your Nikonos V strobe system is designed specifically to help you get those beautiful underwater shots with a minimum of difficulty. With the camera in the A position and the speed light in the TTL mode, once you've metered properly for existing ambient light, the Nikonos V's TTL electronic circuitry will calculate the proper flash duration. When you fire the strobe, the TTL circuitry instantaneously calculates the proper duration of the flash. When you get underwater with your iris preset to f11, you'll see that your camera will probably calculate a shutter speed of a 60th of a second with the existing ambient light. However, when using the strobe in the TTL mode, make sure that your shutter speed remains below a 90th of a second. If there is so much light that your LED shutter speed indicators read faster than a 90th, the TTL circuitry will not function accurately, and your pictures will appear to be overexposed. If your shutter speed reads faster than a 90th of a second, close down your iris until the shutter speed changes into the acceptable range of 1/90th of a second or slower.
Let's simplify what we've just discussed and relate it to what we'll be doing here. We've found that in the warm, clear waters of the Cayman Islands, or in similar waters around the world, under normal sunny conditions, our f-stops will be f11 for dives up to 50 feet and f8 for deeper dives. We'll use these settings for a starting point.
Most professionals are in the habit of going through a standard checklist routine for good reason, and it's a practice you should follow. So once more, before you leave the house, go through the checklist. It's a good idea to bring along extra batteries and film too. Now you're ready for your trip. Once you're ready to dive, go through your check routine one more time. You don't want the excitement of getting ready for a dive to prevent you from preparing your camera equipment thoroughly, nor do you want the excitement about the beautiful shots you're about to take to distract you while preparing for a safe dive. Double check your camera mode selector to make sure it's in the A or aperture priority position. Your ASA ISO setting is set for the film speed you are using. Your focus distance is set for 3 feet. The f-stop at f11, and your strobe to the TTL or through the lens position.
Susan, let me give you one more tip.
Yeah?
Right now you've got the strobe mounted on the inside of the arm. A lot of photographers prefer to have it mounted on the outside of the arm.
Why is that?
Well, it reduces the problem we have with backscatter. Backscatter is caused by the suspended particles in between the camera lens and the subject. If we have the strobe mounted too close to the camera lens, it'll pick up on all of those suspended particles and it'll cause a problem that we call backscatter.
I see, okay.
By moving the strobe further away from the camera lens, we get less of that problem. The light will still come forward and hit the suspended particles, but it will bounce back in a different direction and the lens won't pick it up.
Great.
We also have to think a little bit about the aiming of the strobe. As if we hold it away from ourselves like this, so that we can look both into the lens and into the strobe simply by changing the position of our eyes, we know that the strobe now is aimed roughly at where we want it to be.
Right.
Underwater, we'll check that again though.
Okay, thanks.
We recommend that you don't jump into the water with your camera system. Leave your camera on board when you first enter the water, then your dive master or dive buddy can hand you your system. Below, just before you leave the anchor line, review your camera settings to make sure nothing has changed whilst descending. The next important consideration when shooting underwater is focus. Although this sounds simple enough on land, underwater our perceptions change. If you've ever tried to reach out to grab the anchor rope and missed, you've experienced an optical illusion created by light refraction. The water bends the light rays and objects appear larger and closer than they really are. Since the Nikonos V is not an SLR or single lens reflex camera, you can't simply focus through the viewfinder until it becomes sharp. Underwater with the Nikonos V, we must estimate the distance we'll be shooting, and due to refraction that's not always as easy as it seems. But it is easier to estimate short distances than longer ones. We should always remember that we need to stay close to the subject to get sharp pictures. As we move further away, suspended particles will work together to break down the sharpness of our image. Our speedlight 2 is only effective at relatively short distances, so we'll want to shoot from a distance of about 3 feet. A good way to judge this distance accurately is to extend your arm out towards the object and have it just out of reach of your fingertips. Next, double check to make sure you've preset your focus on the camera to 3 feet. Use the focus knob to preset the focus, don't twist the lens. Remember how back on deck we adjusted the speedlight head to aim at your face from arm's length? That speedlight head angle should properly expose your subjects at 3 feet. When you take your very first exposure, make sure the speedlight is lighting the primary subject. By placing the speedlight head to the outside of the mount, we also eliminate the other underwater problem we talked about, backscatter. Backscatter is caused by the light from the flash hitting suspended particles in the water directly in front of it, reflecting back into the lens as if you were shooting in a snowstorm. These particles are closer than your subject and in the direct line of your lens, and so will show up unless your strobe is coming from another axis. We want the speedlight as far from the camera lens as possible, but still 3 feet from the subject. Each time you trigger your speedlight, it should take about 6 to 8 seconds for the ready light to indicate you can shoot another exposure. The lightning bolt in the viewfinder also indicates when the strobe is ready for refiring. Okay, let's review what we've learned about focus. We know we want to preset focus to 3 feet. Position yourself so subject is just beyond arm's reach, remembering that if we are slightly off, the depth of field will provide a margin of error. Since we aimed our strobe at our face from arm's length, it should be properly aimed at our primary subject, but we'll double check on the first shot, and we'll avoid backscatter by keeping the strobe as far from the lens as possible.
Now that we've talked about the Nikonos V, and we've learned about exposure and focus as they relate to underwater photography, we're now going to discuss what we really came to Cayman to see, the subject matter.
These warm tropical waters we dive in are one of the few places on Earth unspoiled by man. Once below the surface with your camera, you'll probably want to start shooting at everything that moves, or at every coral head. That urge is understandable, for in the waters of Cayman, the mysterious beauty is endless. A lot of what we discuss when we talk about subject matter and composition is how you will interpret that beauty. It's really a function of aesthetics, style, taste, and artistic ability. In other words, it really can't be taught. It's something that you will develop as you grow as an underwater photographer. But there are a few things that we can help you with. First, shoot for an audience. Underwater we'll see large reefs and spectacular panoramas filled with sponges and fish. Although these wide shots may look beautiful to our eyes, if we try to shoot wide shots, we'll most likely end up with fuzzy, bluish colored pictures that non-divers will find difficult to relate to. Instead, we need to concentrate on close shots that have a colourful primary subject, such as yellow tube sponges, parrotfish, or other divers. Fill up your frame with the primary subject. It should dominate the frame and draw the eye. Careful framing is important. Remember, use the lower etchings in your viewfinder for shots closer than 4 feet. Sometimes during topside photography, you need to step back to include more in the frame. But in underwater photography, stepping or swimming back from a subject decreases the effectiveness of the strobe, resulting in blue pictures, and allows more suspended particles between camera and subject, resulting in fuzzy, indistinct pictures. Instead, to increase your field of view on any given subject, you would need to change your lens to a wide-angle lens. A wider angle lens can increase your field of view of a subject from the same 3-foot distance. Of course, this changing to a wide-angle lens must be done above water. Wide angle and macro will be covered in the next 2 tapes in this series. Next, when shooting, try to shoot an upshot. Position yourself beneath the subject when possible, so you have neutral blue water behind the primary subject. Sunlight can often provide an attractive backlight and increase the apparent visibility. If you shoot down at your subject, it places the reef or sand behind your primary subject. The background is then often dark, out of focus and distracting. As you maneuver around to get those perfect shots, remember, no shot is worth damaging or destroying the reef for. Avoid kicking, climbing, or endangering the reef in any way just to get the right angle. Often when framing or composing a shot, you may decide to shoot it in a vertical format instead of a horizontal format. Check your composition both ways to see which is more appealing. If you can't decide, we suggest you shoot it both ways. If you do decide to shoot it in the vertical format, be sure to keep the strobe on top to approximate the angle of the sun. Strobe light coming from the bottom is often unnatural, especially in photographing people. The Nikonos V metering system is very accurate under average conditions with a standard lens, but you should be aware that it does not take into account such things as backlighting or wide-angle shots with a variety of lighting conditions, or a wide range of contrasts such as in this slide where we see very light areas and very dark areas within the same shot. Because your camera's light meter may not be taking all lighting factors into consideration, we suggest the old photographer's insurance, known as bracketing your exposures. Since film is your least expensive commodity at this point, many photographers will first take a shot at what they think is the correct exposure. Then, as a fairly inexpensive insurance policy, they'll shoot one overexposed and one underexposed shot to cover their bases. Ordinarily, this simply means opening or closing your iris stop in each direction, or increasing or decreasing the shutter speed while maintaining the same f-stop. But since our Nikonos V camera system is so smart, it would compensate for any such changes while in the TTL mode. In order to bracket our exposures, we have to resort to another old trick. We're going to fool the camera. We fool the camera to bracket our exposures by telling the camera we're using a slower ASA film and then a faster ASA film than we really are. For example, we've already taken a shot with the ASA indicator set at the correct ASA reading of 100. Now we fool the camera for one shot by changing our ASA setting to ASA 50. The camera will now overcompensate a little and give us a brighter exposure. Next, we fool it a second time and tell the camera we're using ASA 200 film. The camera, thinking we are using a faster, more sensitive film, will not expose the shot to as much light, and the resulting shot will be darker. By telling the truth once and fooling the camera twice, we will have a choice of 3 separate exposures to choose from. This bracketing takes some time to execute and may not always be practical when following some fast-moving creature of the deep, but for your more important shots it is recommended. The most important thing to remember after bracketing is to start telling your camera the truth again. Set your ASA reading back to 100 if that is the film you are using. After each dive, be sure to soak your camera in warm, fresh water. Find out from the dive master ahead of time if there is fresh water available to rinse your camera. If there is none available, you may wish to bring a jug of your own fresh water and soaking bucket. Agitate your camera up and down in the bath and cock the film advance lever and push the shutter release button and all other movable controls to loosen any salt crystals that may have formed. This freshwater bath should remove all salt, sand and debris from your camera. If you unload film on your dive boat, you must take precautions to protect your camera and film. Some boats are not conducive to changing film or batteries since they're open and expose you to the elements. To avoid any unexpected dripping on your camera from your clothing or body, remove the top part of your wetsuit. Dry your hair, shoulders and hands completely. Find a dry place out of the sun and wind, dry the camera completely, change your mode selector to R, and rewind the film using the rewind crank. You will feel the film tighten in the film chamber, and then you'll hear it click as it unwinds from the take-up spool. Hold the camera upside down when opening the camera back. This is to prevent any water, sand or debris from entering the camera. The film canister should fall into your hand. At the end of the day's shooting, your camera needs to be thoroughly soaked for 30 minutes. Again, manipulate all movable controls to remove the salt and sand. Now then, let's review what we've discussed on shooting and subject matter. Shoot for an audience. Select a colorful primary subject. Shoot from 3 feet away. Fill up the frame with your primary subject using the viewfinder guidelines. Shoot in an upward direction with neutral blue in the background. Decide whether subject demands horizontal or vertical framing, and when in doubt, shoot it both ways, remembering that the strobe light stays on top when shooting the vertical format. Bracket your exposures on those really important shots. And above all, remember, it's important to respect our fragile environment so others may enjoy it after you.
The question always arises, is it worth it? Why bother with all the expense, preparation and trouble to spend time underwater taking pictures? At Fisheye here in Grand Cayman, we lead over 3,000 successful dives each year. And over the years, our friends and clients have taken tens of thousands of beautiful pictures using the equipment and techniques we've discussed on this program. Ask any one of these divers and I'm sure you'd receive essentially the same reply. Having tried unsuccessfully to describe the underwater world, they take to underwater photography to more eloquently explain a magnificent phenomenon that few will ever see. It offers us a glimpse into a world unspoiled by man and allows us, however poorly, to represent that world to others. No matter on what level our mind operates, underwater photography will recharge tired batteries, enrich our souls, and bring back fond memories of happy times. Photography is for everyone, and I hope that this program will get you started the right way so that you can enjoy and remember the spectacular reefs, fascinating sea life, and mysterious shipwrecks that make up our underwater world. Until then, I'm Martin Sutton, wishing you great underwater shots.
Fisheye's series of Nikonos instructional videotapes teach you how to shoot with the world's most popular underwater camera, the Nikonos V. Leading you each step of the way in a simple, easy-to-follow manner, they have everything you'll need to become an expert in the exciting world of underwater photography. To order your copies of basic underwater photography with the Nikonos V or either of the advanced underwater photography tapes, call, write or fax to Fisheye, P.O. Box 30076, Grand Cayman, British West Indies. The basic tape costs just $24.95 plus $3.95 shipping and handling. The advanced tapes cost $29.95 plus $3.95 shipping and handling. For orders outside the United States, add $15 for shipping and handling. Send check, money order or credit card information and order your tapes today. They just may be your best photographic tool.